Learn it fast, learn it smart, learn with us at Sofo. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from Sofo Learning. Today our goal is to review angle, 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 side, 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 or side, angle, side theorems for assessing the similarity of two triangles. We will look into each of these theorems, study how to prove them, and more importantly, look at some of the common themes across the proof of each of these theorems. So let's start. I have two triangles over here, ABC and DEF. And what we're going to use, we are going to use these two triangles to prove as the basis of our proofs. But to enable the proof, one of the key things I have done is I found a point P in such a way that DP is equal to AB. So this distance is the same as this distance. I have noted that here AB equal to DP, and similarly on the other side AC equal to DQ. AC equal to DQ. Our first theorem that we are going to look at is angle, angle, angle theorem, or AAA theorem. Now, what are the things that we are given in this theorem to prove the similarity between these two triangles, right? So angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. And now we need to prove that the sides, all three sides, are proportional. That's how we prove that these two triangles are similar, ABC and DEF. Now, how do we show the proportionality of the sides? It's AB by DE, these two sides, and that's equal to AC by DF, this side AC by DF, and that is equal to BC by EF. All right, this side to this side. Now, how do we think about the solution or the proof of this one? What we need to think about is these small triangle DPQ and ABC. Now we know, we can prove basically that they are congruent. Why? Because this angle is equal to this angle. We know that A equal to D, that's our base assumption. And this side AB is equal to DP, and this side AC is equal to DQ. So we know for a fact that triangle ABC is congruent with triangle DPQ. So this is the first step. All right. Now, what does this prove? What do we get from here? Is that angle B is equal to angle P, angle B is equal to angle P, and is also equal to angle E, angle E. Now similarly, angle C, these two triangles are congruent, so this angle and this angle are equal, this angle and this angle are equal, and this angle and this one are equal, right? So C is equal to Q, which is equal to angle F. All right. Now this now shows that this P and E are equal. All right. So this P and E are equal, and this Q and F are equal. Alright, that very clearly means that this line PQ and this line EF are running in parallel. Alright, let's write that down. PQ is running in parallel to EF. Alright, now this helps us a lot because we can now apply the basic proportionality theorem to these two triangles and show the proportionality of the sides. Now the theorem basically states that since these two are running in parallel, this side and this side, that proportion is equal to this side and this side. So let's write that down. dP divided by PE is equal to dQ divided by QF. Alright, now how do we derive the next step from here? We kind of need to do a little bit of arithmetic to the sides of this equation by adjusting it with a 1 value. Let me show you. Okay, so we are going to invert this equation on both sides. So we will say PE divided by dP is equal to, let's invert on this side as well, QF divided by dQ. Now let's add a 1 to this side, and the 1 will be represented as dP by dP, and on this side we will add the 1, but we will add it as dQ by dQ. Alright, now the denominator is the same, so the addition means numerators are added. PE plus dP. PE plus dP is dE, so this will become dE, the numerator, divided by dP is equal to, and on the other side the same process applies, a very similar process applies, and then you get dF divided by dQ. Let's now invert this back, and we should apply, say, dP by dE is equal to dQ by dF. Now we know that dP is equal to AB from the original triangle, so this is AB by DE is equal to dQ is equal to AC by DF. Alright, so this here we have proven that two of those sides are proportional. Alright, now let's imagine that instead of drawing this line between the sides DE and DF, we chose another combination. Right? So if we turn these triangles around and draw this line in parallel with the DE side, so let me kind of change the color and show it to you. So if we had drawn like this, right, then we would have theorized another two sides, and if we had drawn parallel to this one, we would have drawn another two sides as equality to the process. We would have gotten a very similar result, but with a different set of sides. Right now, when we drew like this, we connected this side to this side and this side to this side. So if we drew like this, we would connect this side to this side and this side to this side, right? So ultimately what we are saying is, we don't have to go through this entire process again. We can just simply repeat this process and prove and keep proving that all sides are essentially proportional. All right, that's basically the angle theorem.